Hi, Steve.
Hello there. How are you, Bruno?
I'm fine, but I would like to know what you do. What is your job at Microsoft?
My job at Microsoft, I'm a product unit manager, and I work in an area of Microsoft, a part of developer division. So developer division is the piece of Microsoft that does .NET, we do Visual Studio, we do the expression tools. So basically anything that is for developers or even close to developers, that's what we build in DevDiv. I work in a piece called Parallel Computing Platform. My team specifically builds all the tools that integrate within Visual Studio that help developers build parallel applications. Specifically, my job is managing a cross-functional team of developers, testers, and program managers that all work together to deliver on the engineering of the software that goes into Visual Studio.
Great job. Can you explain why the new Task API is better than Thread API?
Absolutely. Tasks better than threads. So here's the way I like to think about it. When you program with threads, and programming with threads is something that the world's gotten really, really good at because we've been doing it for many years. But it really requires you to think like the machine. When I'm thinking in terms of threads, I'm thinking about execution flow of my program through the machine. What I'm not thinking about is the chunks of work in my program. So I find myself within the architecture of my program using threads, I have to retrofit the idea of work in my program to how things are going to be executed along threads. Tasks allow you to think a little bit differently in a couple important ways. One is they allow you to think in terms of bite-sized pieces of work instead of execution flow. So you don't really care how the flow of execution of tasks occurs in the machine. You just know, here's a chunk of work. That's a task. Go schedule it. And here's another one. Go schedule it. And you don't really care how that happens through the system. The other important way that tasks are different is they're lighter weight. And so where threads, you kind of have this very expensive spin-up process to create threads and tear-down process to destroy them. With tasks, they're much, much less expensive. So you find that you can create, with very low cost, lots and lots of tasks, throw them at the scheduler, and the scheduler knows how to account for these things and knows how to efficiently schedule and execute them. Now, that's kind of the core execution-oriented differences. From an API standpoint, tasks just give you lots of cool stuff that you come to rely on as a part of normal programs. So if I want things like cancellation, I want things like exception handling support. If I want things like the ability to compose tasks. So I have a task here, and when that's done, I want to run this one, and when that's done, I want to run this one, and then I want to run these two at the same time. And when all those are done, I want to run this other one. And those kinds of patterns are actually really, really easy to build with tasks, and those are fiendishly difficult to build with threads and really difficult to get right. So those are some of the core differences, I think, between a task-centric programming model and a thread-centric programming model.
And do you think about memory? It's quite different, no?
The way you can consume memory, a little bit different. I would say you face, at the end of the day, a task-centric programming model is still hosted on top of a thread pool that services the tasks. So in many ways, you have to worry about race conditions, and you have to worry about deadlocks, and you have to worry about the same kinds of things that you would worry about if you were doing a threaded programming model or even using a thread pool. But I would say that the programming model that is provided around it for you just makes it a lot easier. It makes you have to worry about some of the things a little bit less. In terms of how you would use heap memory, you have to worry about it a little bit less. In terms of how you would think about stack, you probably think about stack in very much the same way, irrespective of which of those two programming models that you're in.
Okay.